What is meant by machine learning? Machine learning is nothing but machine learns. The word clearly indicates that machine learning means machine is learning the data. So whatever the data you are providing to the machine will read that data, will understand that data. So just it is going to read the data or it understands the data. Means machine learning is subfield of computer science that gives computer the ability to learn without being explicitly programmed. What is the meaning of this one? Means simple, very, very simple. This is a traditional programming. General, whatever the Python programmers or any developers are there, they are called as traditional programming, normal programming versus machine learning. What is the difference? In the traditional programming, for example, we are having the X. This is the X column. 1, 2, 3, 4, 5. This X column is called as input data. This X column is called as input data. And I am going to write the next one called as plus 5. Plus 5. Plus 5 means it is nothing but the code. This is called as code. Now, and next it is going to give the output as a new column called as Y, which is equal to nothing but 6, 7, 8, 9, and 10. And this is called as output. You are writing the input and you are writing the code, and based on the code, it is going to generate the output. Means to be more simplified, this one, how we are going to write this one means in general programming, first we'll take X is equal to 1, 2, 3, 4, 5. Okay. And Y is equal to an empty list. We'll write an empty list. For I in X. For I in X. Okay. It is going to calculate the C is equal to I plus 5 and Y dot append of C. Y dot append of C and print the Y. So now what it is going to do output? The output will be 6, 7, 8, 9, and 10. This is the output. Now, just don't write, just focus clearly. This is called as input. This is the input. Whatever the input they are giving, whatever the list of values, in the list of values 1, 2, 3, 4, 5, instead of 1, 2, 3, 5, 4, write 10, 20, 30, 40, whatever it is. Some input values. For the given input data, we have to add the 5. That is the program. For the given input data, we have to add the 5. Write the program for that. Means write the code for that. You have to write the code and finally you have to get the output like this. This is called as traditional programming. In the traditional programming, we'll have some input. And for that input, this is my required output. They will only tell the output. For example, I'm saying this, how they are going to ask the same thing means as a question like this. How they will ask the question? Question is in terms of like this. Now, what is the question means? For the given list of values, add 5 for each value. Or add 5, write a program, or let us write like this. Write a program for adding 5 to each value in given data. That given data might be data frame, that given data might be list, that given data might be anything. Based for the given data, they have to write. That is the requirement. Now, if it is a data frame like this, assume it is a data frame. Now, what you are going to, this is the list means this is the code. We'll write the code. Input is a list. We have written the code and this is the output. Now, if it is a data frame, now for the data frame, what we are going to do? If it is a data frame means we are going to select traditional programming only. Pandas also comes under traditional programming only. Now, in the df of new variable y, it is going to create a new variable y with respect to df of x plus 5. Now, for whatever the x variable we are having 1, 2, 3, 4, 5. This is x. Now, y will be created. This is the output. Output will be created accordingly 6, 7, 8, 9, 10. This is the output and this is the code. Input they have given and you have written the code and you are seeing the output. This is the normal program till now we have done, right? Now, the same thing in the same thing in machine learning, what will be done, you know? Now, what is machine learning? You will understand for the same example. Okay, in machine learning, you are going to write the input common. X is equal to 1, 2, 3, 4, 5. Don't write the code. You have to write the output also. Output also you only have to give. That is 6, 7, 8, 9. And it will give the output as code. Output is code. You have to give to the system both X values and Y values. And now you have to ask what is the relation between these two. Now it will tell the relation between Y and X. The relation is Y is equal to X plus 5. This is the output. It is going to give the output like this. Machine learning means identifying the relation between the input versus output. Machine learning is with respect to identifying the relation. Whatever the relation between the input and output is there without writing the code. I have not written the code. Code, it will only do automatically. For example, 1, 4, 9, 16, next number. Now what is this number? And everyone knows this answer is 25. Everyone says the answer is 25. How? Did I told you that 1 square, 2 square, 3 square? Did I told? You only applied the logic. You only applied the logic by seeing the data. By observing the data, you applied the logic and you have predicted the answer. Same thing machine. If the same thing was done by the machine means, it is called as machine learning. What you have done? Because who have answered this 25 means whoever has learned this one, the sequence or whatever the series that in the aptitude test they have learned this one. Within the aptitude, whatever this series concept is that whoever has learned, for them it is easy. Whoever has not learned, they have not answered. Means learn. First you have learned. Na? Similarly, machine also. First machine has to learn. If machine learns means it will also predict the answers like this. If the machine does not learn means it will also not predict. It will also not say answer. If I ask question means it will also see like this on. It will also not answer. It will give empty, nothing. Once it learns means it will give the answer. So now the same thing. See, for example, what I'm going to do is feedback is there. I'm having the feedbacks like good word. Good word is called as positive word. Bad word is called as negative word. Average is called as neutral word or something. Next, for example, average also I'm taking as a positive word. Assume. Next, awesome, positive word. And nice, positive word. Excellent, positive word. Worst, negative word. Now, these words I'm going to train to the machine. I will train the machine. These are the words and this is the one. Now, SRK is a good trainer. There is a comment. Some student has written the comment. Whether it is a positive comment or a negative comment. How? Because you have observed the word of good and you have learned the English language. Now the same thing, it will also do the same thing. It will check whether this word belongs to good, this one or bad, that one. So for example, there is something like this. SRK is a good trainer, but very fast. Exhume. I also know. Now SRK is a good trainer, but very fast. It is there like this. Now it is going to apply for good, whether it belongs to which category, positive or negative. Okay. Next, very belongs to which category, fast belongs to which category. For each category, it is going to check and overall which is having more things. According to that, it will throw. For example, 20 words are there. Out of 20 words, 18 words are positive, 2 words are negative. Overall, that particular sentence will be considered as positive word or positive sentence or negative sentence. Simple. Now, sir, this same thing is there, right? Now, why you have to give to the machine and why you have to ask the machine only like this? You can say that SRK is a good trainer by saying itself, you only tell the answer. Nah? Then why you have to train? For example, I'm having only 10 sentences or 20 sentences or 20 feedbacks means I can do manually. Assume I am getting every day 20,000 feedbacks. Narendra Modi will get throughout India how many feedbacks? So many, right? Now, can he read every feedback manually? Is that possible? The same thing will be given to the machine, and machine will classify how many positives are there, how many negatives are there. For that, first we have to train the machine. These are the positive words and these are the negative words. Machine learning is that. Is that clear? So how you have learned the English, similarly teach the machine also. This word means positive word. This word is negative word. Teach the machine also. First you teach the machine, and after teaching, you expect the answer from that. Without teaching, how you can expect? For example, LKG student is there. Okay, LKG student don't know additions or nothing. First time you have entered into LKG classroom and directly asked 10 plus 5. He will see like this. From top to bottom, he will see like this, and he will be quiet only. He don't know a letter A only. You are asking 10 plus 20 or 10 plus 5. From our perspective, hey, you don't know even this one. We'll say like this. But from his perspective, instead of that, if you train that particular student, first you train what is meant by addition. Once addition is completed, you have trained with 1 plus 2 is equal to 3. 3 plus 4 is equal to 7. 7 plus 9 is equal to 16. You told addition, you only told the answer also. Training also done with answers. With the answers, training was done. Now you are going to check with respect to whether he has learned properly or not. 16 plus 4, what is the answer? This you have to ask the question for the future data. First you have to train on the past data. Okay, machine learning means teaching the machine, and machine is learning the data, is called as machine learning. Concept is clear? Machine will learn the data. Machine learning means machine will learn the data. So now, without writing any kind of program step by step, you don't need to write the program step by step. It will only analyze by applying the different approaches. For example, in this sir, for example, admin has told me that, sir, please observe the students in the class. Okay, and I am observing, and he asked me particular student to observe. I have observed that particular student, assume. Then it is called as implicit program. Means whatever he has told, I am doing that one. Without he saying anything, I am only observing the students. I am only doing everything. Means that is explicit. For example, I have observed that whenever the 6 p.m. batch is completed, whenever the door is open, one student will come immediately. He will rush up. One particular student, assume. I have observed. Now what I am going to say to the student, please wait. Others first they come, total 6 p.m. batch, let they come outside. So you can come. Your first bench, first position will not go. Don't worry. I have to say to that particular student. How I am going to say? By saying the example in the class. Now the matter is conveyed. Right? Simple. This is the way. One of the example. Everyone knows, right? Okay. Now, just by things are without explicit program. I was not programmed that I have to say in this way only. There is no explicit, implicit program is not there. Means there is no step by step. Right? Based on my analysis and based on whatever I have observed, just I'm explaining that one without saying that particular student name. Because I also don't know. First, I don't know. First student name, I don't know. Okay. So here the machine will understand the data. Whatever the data you have given to that machine, it will understand the data. So here, for example, I'm having some, for machine learning, to understand the machine learning very simple way, I will explain with a simple example. Very, very simple example. Assume there is a 2 years baby. There is a 2 years baby. 2 years baby don't know what is cat and what is dog. Assume that baby has never seen that any cat or dog. And you also not teach till now. Till now you have not teach. Assume you are going to teach for the first time. Now, first time you have shown one dog. Street dog you have shown. One street dog you have shown. And the street dog is in brown color. Some height is there. And you have shown this dog. And you told that this is called as dog. And it is doing some kind of sound. And you have told that this is called as dog. Baby has seen like this and enjoyed or whatever it is. Completed. Task completed. Now next one is you have shown next day one white color dog. That too, short, which is very short, Pomeranian dog. You have shown some kind of. Again, you told dog. It will think that, very stupid. Yesterday you told that one dog. Today you are saying this one. It will understand. It will think internally, right? Internally, what is the baby's mindset will be there? Yesterday only told that much of big one is called as dog. Suddenly you are showing this one dog miss. So here, based on one single example, we are not going to conclude. We can't conclude everything based on one single example. So here we are going to take the data. In the database, the data will be there. And this database we are going to give to the machine learning algorithm. And the machine learning algorithm will extract the futures. And it will predict the based on that. Is that clear? Now, within the machine learning, we are having multiple algorithms are there. For different scenarios and different purposes or situations, and based on that, we are going to select the different algorithms. Out of which the first algorithm is called as regression. Regression means where you are going to estimate the continuous variable. For example, mileage of a car. Mileage of a car is a continuous variable or any discrete variable? Continuous variable, which is with respect to 14.2, 16.8, 16.7, 16.6, anything can be there. Any value can be there. 32.4, anything can be there. So which is a continuous variable, 32.41, 32.401, any value. It is a, so whenever you are predicting the output variable which is continuous, then it is called as a regression problem. Where you are predicting the output variable which is continuous. Output variable is continuous. Which you want to predict. The output which you want to predict. Example is mileage, salary of a person. Based on the input data, salary of a person you want to predict. Based on the number of projects, based on the tools, based on the skill set, based on the interview score, based on the whatever the test, and based on the certification, and all these input parameters. By considering various input parameters, you are calculating the salary. Finally, you are predicting the salary. Right? So, mileage, salary, for example, used car price. You want to predict the used car price. That is also a regression problem. Right? House price. That is also a regression problem. This house price will be dependent on the square feet of the house and what is the locality and distance from the metro station, distance from the landmark, distance from the graveyard. It is going to depend on the multiple parameters. Number of bedrooms, what is the facing, east facing or west facing or something. And total how many floors are there in that, which floor this particular apartment is belonging. Like this, it is going to depend on various parameters. All these parameters by considering, and we are going to predict that one. Whatever the input parameters they have given, using that input parameters, we have to predict the output variable. If that input parameter is not available, means don't consider that one. If it is available, means consider that one, and based on that, predict the output. Right? Next, classification. Classification means where you are going to predict the output variable, which is discrete. Means whether to approve the loan or to reject the loan. Approve or reject. Discrete variable, right? That particular column will have only either approve or discrete. It will not have 1.1 or 1.2, nothing, right? Either approve or discrete. Classes are there. In the output variable, we are having the classes. Whether the person will join this course or not join the course. Okay, whether the person will understand the class or not understand the class. Whether the person will get the job or not get the job. Okay, whether they belongs to this upper category A or category B or category C. Anything. Minimum 2 classes to maximum any classes. But the output variable should have classes. Categories should be there. If the output variable is having only 2 classes, means it is called as binary classification problem. If it is having more than 2 classes in the output variable, means it is called as multi-class problem. Is that clear? Now, for example, based on the some politician, one politician is there, and the politician is having some kind of symptoms or with respect to what to say, futures or based on that. Now we have to predict whether this person is more suited to Congress or more suited to BJP or more suited to TDP or TRS, like this. Now output variable is multi-class problem. Within this only you can say, you can't say additional to that. Whatever the classes are there, within that only you have to predict anyone. If I give the option yes or no means you have to say yes or no only. You can't say option C, sir, both yes and no. Option D, none of the above. You can't create the options. You have to predict either yes or no only. You can't create the new option in the output variable. What is meant by clustering? Clustering means grouping of similar people. Grouping of similar people is called as clustering. Clustering is simple. Friends. You'll make the friendship, right? To whom you'll make the friendship? Similarity. How many similarities you are having with your friend? More similarities are there means close friend. Less similarities are there means less friend. Right? So making the friendship is called as clustering. Means grouping the similar objects. Grouping of similar objects into one is called as clustering technique. Next one is association. Association means along with this one, what is the other one most frequently occurring commonly? For example, if you go to a supermarket and if you are asking any toothpaste, what is the commonly you will purchase along with the toothpaste? Most commonly. You will not go with respect to paste and you will not ask with respect to chicken along with that, right? You will not ask with respect to along with the paste and with respect to Vim soap or nothing. So most commonly which one is there? Of course, that one also will be there. But most commonly which one is there? That is finding the pattern you are finding. Now, once you find the pattern, according to that, you are going to make the combo offers. So first we have to observe the patterns. What are the previous transactions are there? Based on the transactions, just observe that one. Based on whatever observations you have made, from that you are coming with a solution. That is analysis. Just common patterns. Along with the paste, the brush will be attached as a combo offer. Along with the cool drink, chips packet will be attached as a combo offer. Along with the beer bottle, whatever the stuff is there, that will be attached as the association, combo offer, right? So, which is most frequently brought items that you are going to observe. Generally, this association will be applicable in the supermarkets. That is the reason it is called as market basket analysis. Association rules are also called as market basket analysis, which is most commonly repeated. Is that clear? Do you know that one of the supermarket in Canada, they have applied the association rule. Before to association rule, then they didn't identify that common thing. After applying the association rule, they have identified along with that in the supermarket beers also will be available. With the beer packet, generally, what will be the combo? Generally, something you are expecting now, which is unexpected one. Diaper is the combo. They have observed that one. Along with the beer, diaper, most of the people, just born babies, they'll be get frustrated because they will not sleep and they will not allow the fathers to sleep during the night hours. So these people generally take the beer. So while taking the beer, they have taken the diaper to home. After observing, their sales of diaper has suddenly increased. How they have increased, you know, keeping the diaper and beer bottles side by side. After that person is interested actually to come with diaper only, but by seeing the beer bottle side, this is original story. If you want, you can check in the Google also. Type in the Google diaper -beer. You'll get the story. You can see entire story. You can see this story also. I'll explain in the association rules class. Don't worry. Like that, we are going to identify the hidden patterns. Some hidden patterns. That is not Walmart. Something is there, but I don't remember exactly. That is not Walmart, right? Similar kind of Walmart only, but not exactly Walmart. Next one is called as anomaly detection. Anomaly detection means where it is going to identify the abnormal data, which is called as outliers. Abnormal data, which is called as outliers. Okay. So what is the difference between anomalies versus outliers? For example, in this class, assume that this class is data science. In this data science, students are sitting. All the data science students are sitting. and one student, full stack student has came and sit in this class. He is called as an outlier. This person is called as an outlier, which is completely different. This is called an outlier. But within the data science students, one student will continuously ask the doubts. He will not accept the trainer to explain the next topic. For every slide, sir, I doubt, sir. Sir, doubt, sir. He will ask like this, na? That person is called as anomaly. He belongs to the class only, but disturbance will be there. That is called as anomalies. Now in the data, anomalies will be there, outliers will be there, influential values also will be there. And we are going to we are going to treat accordingly. In the future, you can see that one. Second one is called as sequential mining. Sequence mining means order. Sequential order is important. For example, stock market is there. Stock market, for example, last month 30th. Okay, whatever the data is there, based on that, you can't predict today's value. Today's value will be dependent on the yesterday's value, not on the last month 30th. 30th November is not used for predicting the 2nd December. So in order to predict the 2nd December, 1st December value is important. Sequential order is important here. Time series data means sequence mining. Cross-sectional data, whatever we have discussed till now is cross-sectional data. For time series data, we have to apply the sequence mining. Mining means digging into the data and extracting the useful information. Understanding the data and getting the useful information is called as mining. Okay, that is nothing but analysis. Time series analysis. Sequence mining is also called as time series analysis. Both are same. Next one is dimension reduction. Dimension reduction means we'll have multiple variables are there. So many variables will be there. Inside that so many variables, we are going to select which are important variables and we are going to remove some of the variables. It's called as dimension reduction. Okay, dimension reduction is nothing but reducing the number of futures, number of columns. Reduction means reducing. Dimension means variables. You are reducing the number of variables. Total 500 rows, 500 columns are there. You are just bringing to 300 columns, reducing them. Now assume that for dimension reduction, we are having two types of techniques. Two techniques are there. One is called as future selection, which we are going to discuss in the further classes. In the previous class, one of the student has written in the chat box, sir, when we are going to discuss this future selection. In order to understand the future selection, some more topics you have to understand. So in the future class, we'll see this one. The order, whatever the order is required, in the same order we'll move. Right? Next, we are having next one is called as future extraction. These are the two options we are having. In dimension reduction only two are there. What is the difference between these two? As of now, I will explain simple way. For future selection, one class, exclusive class we have to take. For future extraction, one class separate is there. Just I am giving an introduction, just as an introduction for you. What is the difference between these two? Means assume in a company, total 5 employees are there. Employee 1, employee 2, employee 3, employee 4, employee 5. And you are not having the money to maintain 5 employees. You are having only money to maintain 4 employees only. You want to delete 1 employee. Okay, you are not having the money with you to maintain 5. What you are going to do? You are going to delete the employee number 1. Assume. It is called as future selection. Now, what is meant by future extraction? This employee will have some content, right? Some matter is there, right, with that person. Means he will have some subject knowledge. Now, I want to use that subject knowledge. How I can use that subject knowledge? I will ask this person to share his knowledge to others. So, by conducting some kind of webinars or seminars or something, and I will ask this person to share the knowledge. Now, after sharing his knowledge, now I will remove his. Now, what is called as use and throw. Use and throw is nothing but future extraction. You will use and you will throw away. Delete that one. By applying the concept called as covariance. Statistically, covariance. By applying the concept of covariance, this will be done. Variation of one will be observed in the second one. Right? That you will see in the later. Example only I have told you. Directly if you remove this, Simple, future selection. Unimportant variable, simply delete. For example, I want to predict the job, whether you'll get a job or not. For predicting the job, your father name is important for me. Yeah? Your name only not important. Then what is the use of your father? So your name only not important for predicting the job. For predicting the job, how much subject you are having is important. How many projects you have done is important. What is your height is not important. What is your weight is not important. Whichever the columns are not important for predicting that one, that columns directly are going to delete. Is called as future selection. And by using and throwing that one is called as future extraction. Both the techniques we are going to learn in the future. Okay. Everything I'm saying in a comedy way, but seriousness will be with respect to when we enter into the subject, that is max. Max will be the serious. Right? Now, recommendation engines. Recommendation engines means PCM is principal component analysis. Algorithm name. Algorithm name. PCA. Okay. Now, next one is recommendation engines. Recommendation engines means it is going to recommend us based on the whatever the past we have purchased or whatever the things we have done. Based on that, it is going to recommend. Right? That is called as recommendation engines. Like Netflix. In the Netflix, YouTube, Amazon Prime, Spotify, all these works on the net with respect to recommendation engines. For example, in the Spotify, you have listened to the various songs with respect to melody songs. Last 10 songs, you have listened to the melody songs. Automatically, you understand that you are the melody lover. And it is going to recommend you the one more melody song only, while it will recommend with respect to other songs. Right? Based on whatever the data you have used in the past, it is analyzing that one, and what is the common thing is there inside that, it is identifying the hidden pattern. For example, everyone are having the Gmail and everyone are using YouTube, right? If you have Gmail or also no, if you don't have also no problem. You are using the YouTube. In the YouTube, first watch one particular clip, that movie. For example, you are watching one movie. Assume movie 1 you are watching, and next you are watching movie 2. Movie 1 is called as Bhimla Nayak. Assume. Second one you are selecting with respect to similar kind of movie with some PK movie only. You are selecting something like Kushi. Assume. And third you are selecting with respect to one more movie. Okay, Gabbar Singh. Now it will understand that you are a PK fan. By observing this one, it will clearly understand that you are a PK fan. Whenever you have clicked on the movie 4 related to PK, it will throw the ad. And that ad also you will see. Compulsory you will see. Because there is no skip ad for that. Right? And it is going to make the revenue on that. So just it has observed the whatever the movies and whatever the playlist you are having. Based on that, it is going to understand the data between that. And based on that, it is going to recommend us this one, new one. Whatever it is going to recommend, obviously we'll see, because it will be almost close to our taste only. Whatever the previous one we have watched, according to that only, it will be there. For example, you have watched with 2 hours movie, 2 hours movie, 2 hours movie. Why it will recommend 5 minutes clip? It will always recommend the 2 hours movie on. You have watched earlier 5 minutes, 5 minutes, 5 minutes, 10 movie clips you have watched with 5 minutes. Next recommendation also will be 5 minutes only. It will not recommend 2 hours movie. You will not watch the 2 hours movie. Na? You are not interested to watch the 2 hours. It will understand. Not based on single one, based on the time only, or based on the hero name, or not based on the single parameter. It will consider multiple parameters. Based on the multiple parameters, whatever is there, it is understanding and it is going to recommend according to that. And after recommendation, now, okay, sir, it is recommending. What is the use? Now it is going to generate the revenue by posting the ads. Right? That is with respect to called as recommendation engines. Is that clear? Now, inside the machine learning, we are having 2 types. One is called as supervised and the second one is called as unsupervised. Supervised means where output variable is available. Unsupervised means no output variable. Without output variable, directly you are working the machine learning algorithms are called as unsupervised machine learning algorithms. Supervised means if the output variable is also available, then it is called as supervised. Without output variable, directly if you are working, then it is called as unsupervised machine learning algorithms. So now in earlier, whatever we have seen this one, these two, regression and classification only belongs to supervised machine learning. Whereas remaining everything belongs to unsupervised. Clustering is unsupervised. There is no output variable. Based on whatever the data, we are common things we are identifying. Common things. Which are the most common things are there? Just we are identifying that one. So association rules, all this comes under unsupervised only. Only these two are supervised. Remaining everything are unsupervised. These two, along with these two, one more. This one also. So sequence binding also supervised. Because this is also having the output variable. Input and output. Input is nothing but time data. Output is whatever the value. Only two columns will be there. One is time versus output. So remaining everything comes under unsupervised. There is no output variable. Without output variable, if you are applying the machine learning algorithms, then it is called as unsupervised. With output variable, it is called as supervised machine learning. So with output variable, it is called as labeled data. If the output variable is available, it is called as labeled data. If the output variable is not available, it is called as unlabeled data. Okay. If the output variable is available, that data set is called as labeled data. If the output variable is not available, that particular data set is called as unlabeled data set. For unlabeled data, we are going to apply the unsupervised machine learning. For labeled data, we apply the supervised machine learning. Is that clear? Now, and here we are going to do the evaluation. These evaluation techniques you will understand in the later. Automatically by understanding the first algorithm itself, you will understand the difference between these two. Now, what is meant by classification? Classification means where you are going to predict the output variable is categories. So for example, this is a malaria data set where we are having in the output variable whether the person is having the malaria or not. Yes or no. That is benign means no malaria, malignant means with malaria. Now this is the data where I am having in the output variable. This is the output variable. This output variable you have to predict based on the input variables. Based on the input variables you have to predict. First, you are going to select the some data, and using this data, the machine will learn. After once it learns, now in the future data, it is going to predict. These are the data it will learn. First it will learn. After learning, for this new data, what is the expected output means it is going to give the output. Before to that, first it has to learn. The data which it will learn is called as training data. Train data. Train data means which is used for training purpose. So for example, in the class, I am going to teach you some slides by using the slides. I am teaching you, right? These slides, whatever the notes is there, this is called as training material. What are the assignment questions I am going to post in the assignments folder, that is called as testing material. Right? So that is testing data. This is training data. Both are material only. Data is nothing but here material. One is used for training purpose and one is used for testing purpose. Right? And if the machine, why you have to test the machine? For example, let us take like this. There is a stock market. In the stock market, we are having a particular share price of a company. Assume that company is Infosys, Infi. And as per the dates, every day wise, we are having as per the day wise, this is the price. On the day 1, this is the price. On day 2, this is the price. On day 3, on day 4, on day 5, day 6, day 7, day 8, day 9, day 10, day 11. Now, using this one, you are going to combine the line graph like this, line plot. You are going to just make a line plot. Okay, line plot also ready. You have placed the dates on the x-axis and the values, whatever the Infosys share price is there on the y-axis, and you have plotted the line plot. Done. Now, you have trained the machine by giving the data. Whatever the data, day 1, day 2, day 3, day 4, day 5, day 6, 7, 8, 9, 10, 11. 11 days you have trained. Now, after training, now you are asking the data, asking your machine on 12th day, what happens? You are asking to predict. Now the machine is predicting this is going to increase. Like this, it is predicting. It will say is correct. If it says correct mark, 100% it will go like that only. If it says everything 100% like that means I will be not here, you will be also not here. I will be in the National Stock Exchange area and you will be in that area, obviously. Right? Now, here with respect to, now what I am going to do first, from day 1 to day 8, up to here, I am going to give to the machine to learn. Now it has learned. Now after learning, now these 3 days, remaining 3 days, whatever it is there, I am asking to test. You predict. From here to here, I am going to give. I will not give the original data. This answer I will not give. This one I will not give for the machine to, I will not train also. I will train from here to here only. Means part of the data I have used it for training purpose. Now, I will ask the machine to predict the answer. For remaining 3 days, what is the answer? Now the machine was predicted like this. Now with the original answer and whatever the machine was predicted answers, I am going to compare, and that is called as accuracy. To check the accuracy, we are using the test data. Is that clear? How much it is predicting correctly. How much it has learned correctly. To check that one, how much it has learned. Whether it has learned correctly or wrongly. For example, I am teaching so many concepts for you. If I keep a test 100 marks, if in that how many you are writing the correct answers, that many marks, right? Similar way. Just in the examination, I am going to give a different data. Whatever I have explained in the class, whatever the examples I have discussed in the examination hall, I am not going to give the same questions. I will give a different questions. On the different data, you are predicting the answers. You are writing the answers. The original answers are there for that. Already I am having the original answers. I am going to compare whatever the original answer I am having, the original answer, and whatever you have written in the examination paper. These both are matching or not. If both are matching means I will make a tick mark. If both are not matching means I will make a cross mark. And based on that, I will give the marks. That is called as evaluation. So here also the same thing will be done. The first the machine will learn, and after that I will evaluate the machine, how much it has learned properly. For example, it has learned correctly, 100% it has learned correctly like this. Perfectly, 100% it has learned. Then whatever the future it is going to predict also 100% answer. If the prediction is 90% correct, the future also 90%. Whatever it is going to predict the future value, it is also 90%. If it is predicting 80%, the future value it is predicting also 80%. Right? So it has understood 80% of the data. According to that, it is predicting. For example, data science exam I have kept for you. And you have got 100 out of 100. What is the meaning of that? You know the entire subject. And based on that, you can do the next one. You have got with 80 out of 100. In the future, whatever the project I am going to give, in that, what is the probability that you can complete that one means 80% only probability. Because you know 80% of the subject only. You know 80% of the subject means 80% of the project only you can complete. How you can complete 100% of the project? Remaining 20%, we have to guide you. If you are having 10% knowledge only, 90% we can't guide. So that is the reason we'll reject. None of the person will have 100% knowledge, but we'll try with the maximum knowledge. Whoever the persons are having the maximum knowledge, we'll try to hire. So that guidance will be less. If you are having 85% knowledge means 15% only our guidance. If you are having 90% knowledge means 10% is our guidance. So just based on that, that is called as evaluation. We are going to evaluate the model. Okay, model is nothing but machine learning algorithm. Model is nothing but machine learning algorithm. Technically, the machine learning algorithms are called as model. Right? Now, clustering is grouping of similar objects. Now, how we are going to work on the machine learning means by using the libraries like Pandas, NumPy, SciPy, Scikit-learn, and Matplotlib. Now, out of which Pandas was completed, NumPy was completed, Matplotlib was completed, and SciPy also completed. Now, just we are going to learn the new library called as Scikit-learn. Sci means scientific, kit, KIT means kit, scientific kit, learning, scientific kit learning. That is the meaning. Shortcut we used to call as sklearn. Full form is scikit-learn, shortcut is sklearn. So we are going to learn the library called as sklearn. Within the sklearn, multiple libraries are there. Sorry, multiple algorithms are there. And we are going to use those algorithms and we are going to work. Just import and fit the data. Coding is simple. Machine learning code is modeling. Modeling means first machine has to learn the data. Na? Machine learning is called as modeling. Algorithm is called as model. Learning is called as modeling. Now machine is learning. How it is going to learn? Import that machine learning algorithm. And whatever the algorithm you have imported, dot fit on the given data. It will learn. 2 lines completed. Machine learning model is 2 lines only. 1 line is import and 1 line is fit the data. You want to evaluate your model. Model dot predict. First you ask the predict. Means it. First you ask the answers on the test data. First you give the test paper and it will give the answers. This is called as answers. Cross verify the answers. Whatever the answers it has given, cross verify that one. Model, it has predicted some answers. Using that answers, whatever the original answers and predicted answers. Original answers, comma, predicted answers. Check how many of them are correct is called as evaluation. This is also 1 line. This is 1 line, this is 1 line, this is 2 lines. Every algorithm is 4 lines of code. But every algorithm is, the detailedness of the max is important. In the interview, they will not ask this question. In the interview, they'll ask with respect to how that algorithm is working. When you are fitting the data, in what is the backend, how it is learning, in what process it is learning. I'm giving a textbook for you and I ask you to learn. Simply I ask you to learn. How you are going to learn? Whether you are going to start from the first page or you are going to identify wherever the important questions star marks are there, directly going to that page, or cutting the page and keeping in the pocket. In what way you are going to learn? Different ways are there, right? That is important. Right? So in that way, we are going to check. So the coding part will be very simple. Coding part is dead easy. Right? Of course, every time in the word dead easy will come automatically because actually that is easy only. Basically that is easy. Right? So if you see this one, first we are going to do the data pre-processing, which already completed. And divide the data into 2 parts. One part is called as training part, one part is called as testing part. But whatever the training part is there, give to the machine, it will learn. Whatever the testing part is there, ask the machine to predict the answers. And whatever the predicted answers are there, just evaluate that one. If evaluation is matching as per the client requirement, the client requires is 80%, and this model also giving 80% accuracy, throw this model to that client. Completed. See, if you are data pre-processing where scaling or standardization or whatever it is there, and train test split. By using the train test split code, we are going to divide the data into 2 parts. One part is for training, one part for testing purpose. And I am going to import the machine learning algorithm, and I have fitted on the X train, Y train. Means input and output also you have to give, right? Both the things you have to give. Input and output. Once the machine was learned, now you ask the machine to predict the answers. And whatever it has predicted, just check the with respect to evaluation. This is called as evaluation. This is called as prediction. This is called as modeling. This is called as train test split. This is called as data pre-processing. If everything satisfies, miss, save the model. If everything not satisfied, miss, restart from starting. Since it is an introduction, I have explained very simple. It is not as simple as what you are saying. Okay. Model is of 3 lines only, but machine learning code is of 200 lines. Okay. So don't worry, everything you'll understand one by one. But just the thing is that the pattern, just you have to understand the pattern, how it is going to understand. Just it is taking the data and it is reading. For example, now textbook is there. I assume that in the machine learning, what is meant by algorithm? Algorithm means nothing but way of practice, way of learning is called as algorithm. Each algorithm will have a different way. Data is same. For example, data is textbook. Okay, this is called as data. I have given to the student number 1. The same textbook I have given to the student number 2. Same textbook I have given to the student number 3. Textbook is called as data. Student is called as algorithm. Same data you have given. Same textbook, same material. Assume not even textbook. Assume that it is SRK material. Okay. Now student 1 is going to practice step by step by doing the revision. First, he will revise whatever was discussed in the class, and he will practice, and he will understand each and every letter to letter. And wherever he is getting the doubt, immediately he will write in the notes that question, and he will check, and again he will come back, again he will practice like this. Student number 1. Student number 2. Already notes is there in the driver, not a okay. Completed. Later we'll do. If it is not there, first we have to ask the SRK sir. Sir, material sir. Collecting the material is important for us. Practicing secondary. This is student number 2. Student number 3. He will see this one and he will revise. Revise means he will do the copy paste work. He will not have the time for practicing. This is student number 3. Now out of these 3 students, at the end, this student has got more accuracy. He has got with respect to 90 marks. He has got with respect to 0 marks. And this person has got with respect to some 20 marks or 30 marks, whatever it is. Now out of that one, which one you are going to select? In the machine learning also same. Same data will be shared to the machine learning algorithm 1. Same data will be shared to the machine learning algorithm 2. Same data will be shared to the machine learning algorithm 3. Data will not change. But each algorithm will do in a different way and come with a different solutions. Out of all the solution, which solution is best? You are going to select that one. Is that clear? So which one is best? I also don't know. We have to try with all of them. By seeing the data, oh, for this data, this is algorithm. No code is fixed. We have to try. And in the entire machine learning, never the code is fixed. No fixed code is there. Entire machine learning, there is no fixed code. You may write in one way, I may write in one way. You may get one answer, I may get one answer. Finally, accuracy will be there, right? Whose accuracy is more means that person has done very betterly. Nothing but machine learning means machine learns. Machine will learn the data, right? Machine learns the data. Right? Now, for example, I told you earlier. Now I want to learn. From where I am going to learn, in what way I am going to learn. Step-by-step process is there, right? If one person will learn in a different time. One person will learn in a different time. For example, generally, what is the time I will learn is morning 5 to 8. This is my learning hours. Okay, this is my learning hours. Some persons learn at 11 o'clock. They'll start, they'll go to room, they'll take the dinner, and slowly they'll have everything. And now at 11 o'clock, they'll get the mood. From night 11 o'clock, they'll start the things. They'll start the learning the things. And some people will start at afternoon, 1 p.m. Some students may start at 2 p.m. Some students may start at 11 a.m. Which one is correct, miss? Nothing is there like that. Is there any rule that if you practice morning hours means you'll get more subject? If you practice this time means you'll get this? Nothing rule is there. Approaches. These are the different approaches. And inside the textbook also, how we are going to practice. That is also one approach. One person will learn in a different way. One person will learn in a different way. Subject is same. From the starting onwards, I am only explaining, right, for you. From the day one, I am only explaining. Now, one person has understand very clearly. One person has not understand, miss. That is my mistake or your mistake. Which one? If none of them is understanding, miss, that is my mistake only. In the class, 80% of the people are understanding and 20% of the people are not understanding, miss. Whose mistake then? Why these 80% of the people are understanding? There should be some reason, right? Because these 80% of the people are practicing. Without practicing, now directly if you come into the class and if you see, miss, though you have not understand anything also, you'll see like this only. Your brain says that I'm not understanding anything, Ra. Please stop, Ra. Your brain says like this, but still you'll see the board like this only, which you'll bluff yourself, na? So each person, that is right or wrong, we can't say that person to person. So here also similarly algorithm to algorithm. Which process is correct, which process is wrong, there is nothing like that. So blindly we have to apply all the process. Sir, all the process we have to apply means so much of time is going to take now. They told that morning if they give the data set, evening itself we have to give the answer. In the company, every one day you are going to complete one project. No, right? The project will be completed in 4 months. Out of which the machine learning, if you are doing particular algorithm, you are applying and you are identifying the betterization and the analysis you are doing is only machine learning itself will take 1.5 month time to identify which is the best algorithm and which is the best one and for getting the best answer. Data pre-processing will take at least 15 to 20 days. So overall the project is 4 months. It is not going to be completed in just 1 day. Morning, your team leader will give the data set. Evening itself, you will submit the answers. Not like that. That is not the competition. Right? In the data science competitions also, everything will be open book only. Nothing will be closed. You can copy the code from wherever you want. Though you copy the code also, there will be no use. Because after the output, you have to do what next step. That is important. If the output says one thing, if you get the output in one way, then based on that, you have to decide. The next code will be decided on based on the previous code output. Right? So for example, if I'm getting 100% accuracy, then why I'll write the next line of code? If I'm getting 40% accuracy, according to that, I will write. Whether next line of code will be decided, first I have to see the accuracy and next line will be decided. 100% is there means I will stop there only. If it is not 100% miss, then I will do. Right? That will be decided after seeing the answer only. Is that clear, guys? So that is with introduction to machine learning.